Okay, for this problem, they want us to find the area of this trapezoid, and the area of a trapezoid formula is as follows: 1/2 base 1 plus base 2 times the height. And really, the only thing we know here, in terms of the formula, is the height. And obviously, the half. We don't have base 1, nor do we have base 2. So we'll have to calculate this. And this is a Pythagorean theorem section of the review. So it's a good assumption we're going to need the Pythagorean theorem. So let's call this A, and this can be B, and this will be C. 12 squared plus C1 squared should equal 20 squared. Okay. And if you solve that, you get the answer. You go to my calculator back in a second. So this base 1 ends up being 16. So this is 16 up here. So I can put that into the formula. Now base 2. Now base 2 is also coming out of a right triangle with this being A. This can be B, and this will be C. Sorry, A, B, and this will be C. This will be A, this will be B, this has to be C. So 15 squared plus 20 squared equals C squared. And let's go to our calculator and get the answer. And so C ends up being 25. So that's actually the second base of the trapezoid. So this is 25. So we have everything we need now in the area of a trapezoid formula. So you can put it all in, add it up, multiply. Get an answer of, let's see here, we get an area of 246 centimeters squared. Okay, the next one we're going to do here is, they tell you it's a semicircle, find the area of it. So to do that, we need to know the area of a semicircle is half a circle. So that's pi r squared cut in half. So we need the radius. The radius will be probably from here to the edge. This is a right triangle, and I believe it's of the format of a 7 squared plus b squared equals hypotenuse 25 squared. And if you do the Pythagorean theorem, the math, you end up with b equals 24. So that is our diameter, and our radius is half that, 12. So we need to put that into the formula up above. Pi 12 squared divided by 2. Be careful not to divide by 2 until you've squared it. So that's 144 pi divided by 2, which is 72 pi. That's the answer in terms of pi. Now, this is a challenging problem. I tell you BT is 6 root 3. We immediately cut this 120 degree angle. Excuse me. So that this is 60 degrees, and this is 30 degrees. We all know that the point of tangency and the tangent meet at 90 degrees. So this is a 30, 60, 90 triangle. You have to pull it out because it's getting very crowded in there. But this is 6, 3. That's the long leg, so we'll have the short leg is 6. And that ends up being the radius. That's about all we need, because the area of the shaded region here is a sector. And the area of a sector formula is as follows. Let's see, the measure of the arc over 360 times pi r squared. And we know r is 6 now. And the measure of this arc, if we peel away all this stuff that we wrote before, and move that line out of the way, 120 degrees here, that means it's 240 degrees around the other part right here. 240 degrees. Okay. Now, this is 240 over 360, so it's 2/3. So if we do some calculating, we'll get the answer. 6 times 6 is 36 pi times 2/3 is let's see, 24 pi, I believe. You can do most of that on your calculator. And this is centimeters squared. Get on to the next problem. Find the area of the shaded region. If the quadrilateral is a square, the arcs are portions of the circles centered R and S, and QE is 2. So this is 2. So that's 2 root 2. And this is a 45, 90 triangle right there. Highlighted for you if you don't see it. There it is. It's a right triangle, special right triangle, 45, 45, 90. So if we pull all that out, we have a triangle over here. And we can identify how big the sides of this triangle are. So remember, if we knew the side, we'd multiply by root 2. So let's assume the side is 2. The side of the square is 2. Great. Now that also happens to be the radius of the circle. It's a little bit hard to imagine, but here's the circle. There it is, sort of going right there. And we've got a quarter of that circle right here. So that's our radius. So what we have here is actually a sector. I'm sorry, a segment. This little sliver right here is what we need to find the area of, and then we'll double it. So what we're going to do is we're going to find the area of the sector, take away the area of the triangle. Okay? That's our goal here. So, area of a sector will be the measure of the arc over 360, so that's 90 degrees out of 360 times pi times radius squared. Okay. And then the area of the triangle will be base times height, 2 times 2 times height. This is 2. The area of the triangle. And the area of the sector will be, let's see, that's a fourth. 1/4 of 4 pi is just pi. So we have pi minus 2. Pi minus 2 is the area of this green segment. And we have 2 of them, so we need to double it. So multiply by 2. We get 2 pi minus 4, which is an approximate answer of 2.28. Okay, the last one says the area of the circle is given. Find the area of the square. Okay, so the area of the circle will be good. We'll use that. So the area of a circle is going to be needed. And they give us the area of the circle. And we're going to divide by pi both sides. 350 divided by pi. Okay, that's r squared. It's about 111. And we'll have to take the square root of both sides. We get r is 10.55. So that's the radius. So that means this distance. Just careful to draw it right there. It's 10.55. So what's this distance? It'll be double that, right? So we'll have to multiply this by 2 to get the diameter. So that's about 21.11. So that distance, the diagonal and the diameter is 21.11. Now that is the diagonal of the square. So I'm going to use a little trick here that I wouldn't typically do. Kites, this is a kite also. So I'm going to take the diagonal times the diagonal formula of a kite. Diagonal 1 times diagonal 2, which will be identical, 21.11. It's going to be easier to do it this way than to treat it like a square. And I don't know what that answer is. Let's check it out on the calculator. Answer of about 222.8. That's correct. That's the area of that square.